evening. My name is Anke Weidenkaff from Stuttgart University, and I'm interviewing Bruce Clemens from Stanford. The big breakthroughs in the future is the hydrogen or the photovoltaic topic more interesting for you?
Well, the hydrogen storage is still a ways in the future. There are starting to be hydrogen-powered fuel cell cars that are coming onto the market soon, but they're all using compressed gas storage. And I think I hope that that's a temporary solution for the issue of hydrogen storage because of the energy loss associated with compressing the gases and also the danger associated with traveling with compressed gas in your car. And that people come up with better storage technologies. But the answer has been tough to find. Actually, a good storage technology has been hard to find. And but I think it's out there, and so we have to do that. In terms of photovoltaics, we've all been a little bit blindsided by the lowering of the costs of solar panels. And so I think that has temporarily, at least, slowed the advance in new solar technologies. But as one of my colleagues put it to me, he said, you know, now we have an overproduction of solar cells, overcapacity in producing solar cells. That's why they're so inexpensive now. But soon the demand will catch up with that. And when the demand catches up, we're going to start building new solar cell manufacturing plants. And what we want to do is be ready with the next generation of what we're going to be making in those plants. And so I think it's a good time to do research in it, even though just about everybody who's involved in the manufacture of solar cells is losing money, I think. And but it has a huge growth potential. Right now, the solar production for the world is on the order of gigawatts or tens of gigawatts, and the world uses power on the order of terawatts. And so we have something like a factor of 1,000 growth potential or something like that. And so it's not like Facebook. They have 1 billion customers and there's only 7 billion people on the planet. So there's not that many industries that have a factor of 1,000 growth potential. So for that reason, it's exciting. And I think people are going to try to find ways to make more highly efficient solar cells at a low cost. And it turns out that efficiency and costs are closely coupled. The idea that you could make a solar cell that was not very efficient but make it really cheap and therefore it would be viable is gone. That idea doesn't work because of the cost of the balance of system, which scales roughly as the area of the solar panel. So what you need to have is highly efficient cells that are low cost. And I think that's what people are working on now. Again, it's a tough market because it's a commodity, and anytime something gets commoditized, the profit margins get squeezed out.
Yeah, that's true. So I just read an article that the materials cost of a solar panel is not the most expensive, so it's just a small part of the whole device. And so maybe where is this relation between, as material scientists, we are now trying to use cheap elements and cost-effective materials, but in the end the device aspect is also to be tracked. And how can the technology and the materials designer work together, or how can we improve that? So are we now running into the wrong direction, that we are always trying to reduce the cost of the material, but we are not looking at the device aspect?
So I think you're right. The cost of materials in a solar cell is usually low. If you just count the cost for buying the amount of elements that you need to make up the solar cell. I had a colleague who works at a solar panel said the cost of their materials that make up the working part of the solar cell is roughly the same as the cost of the box that they ship the solar panel in. But it's the processing that costs a lot of money. And so you need to have high-speed processing in order to reduce the cost of the capital equipment that you need to make these things. And also, for high-efficiency solar cells, so far, the only way we've been able to make really highly efficient solar cells is with very high-quality materials. And I'm talking above the 20% range, but like the 30 on up percent solar cells are all made with single crystal, nearly perfect materials. And so if you can find a way to make those inexpensive, and that's one of the things we're working on in my group, not to toot my own horn, but we've developed a way to do a laser liftoff process to remove a perfect single crystal of gallium arsenide. And of all the materials, gallium arsenide holds all the records for high efficiency solar cell, either as a single junction or a multi-junction device. And so, you know, potentially our approach has the chance to take what is relatively expensive, the gallium arsenide substrate, and turn it from a consumable into a tool that we use just to template the growth of the high quality material, and then pop that off and then reuse it and package our devices and sell them. So I think those sorts of approaches are potentially interesting for producing these low-cost, high-efficiency solar cells that I think we need in order to really get to the next level. But I think for solar, we also have to develop storage, energy storage. Beyond a certain penetration level, if you don't have a way to store the energy, then it starts to compete against itself in a way. So, and I think some countries, maybe even Germany, is getting close to that already now in terms of having issues with being able to use all the solar power that's produced on a really sunny part of the day, and if you can't use it, then it really becomes more expensive because then you're wasting that energy. So I think, you know, right now the grid works with no storage, just about, which is kind of a miraculously scary kind of thing if I think about it. These variable demands, you can go and turn on some big power device and you expect the power to be there. And but I think in the future there's going to be storage, and the storage is going to be at all different time scales, so that there'll be storage that's used for rapid voltage stability control, but also for longer term storage that can take energy from renewable sources and then shift the time to use it when the renewables aren't producing.
So if we are thinking about chemical storage, still the best energy storage material are the hydrocarbons, and of course hydrogen. If we solve these issues of the storage, then this could be interesting. But what do you think? Where's the place, or this? Maybe if we have a future hydrogen society, how do we get there? What would be the intermediate step, or can we create new hydrocarbons by artificial photosynthesis reactions?
I think at this point we have to keep all our options open. And I think you know, making hydrocarbons using some sort of photocatalysis process is something that we should be pursuing. Obviously we're equipped to deal with hydrocarbon fuels now, and we're not ready yet. The way I say is hydrogen, we're ready to use it as a fuel now, except for problems in production, distribution, storage, and use. Other than that, we're ready to go. So, but that doesn't mean we shouldn't work on it, and it's a remarkable material and will be a great fuel if we can solve those problems. So I think you know, I think we don't know enough yet to know what is going to be the answer. So I think to choose it at this point would be a mistake. I think it's good to keep a lot of different things going and try to see, you know, pick the few winners as time goes on and focus on those. So.